Hi, we're going to do a horizontal launch projectile motion problem. Horizontal launch problems are the only kind we're going to do in this class of ours, and the math is relatively simple compared to some of the other types. Now, the key to these is understanding that a horizontal launch means that our initial velocity vector here only has an x component, and the y component is always 0, because any vector that is horizontal has no vertical component. Now, in this problem, let's read this really quickly. Harry accidentally falls out of a helicopter that's traveling horizontally at 100 meters per second at an altitude of 50 meters. Luckily, he lands in a pool. How long does Harry take to hit the water, and what was the horizontal distance between Harry and the pool when he fell out? Okay, so we know that his horizontal speed is 100 meters per second. We know the distance he fell vertically is 50 meters. And the things that we want to know is we want to know the time it takes to hit the water and how much his horizontal distance is. Okay, let's draw a little picture here. So here's my helicopter flying along, doing its thing, and Harry falls out and goes plop. Okay, now the vertical distance straight down is this 50 meters that we know, and this horizontal distance we do not know. Okay, so I'm going to call that dy. Okay, the little x's and the little y's just mean horizontal and vertical. Okay, so we have a couple equations that we use for this. The one for the horizontal motion says that the distance that is horizontal equals the initial velocity that is horizontal times the time. It's a real simple equation because there's no acceleration in the horizontal direction. Now in the vertical direction, we have that the vertical distance equals 1/2 the acceleration of gravity times t squared. That should look kind of familiar to you. That's the same equation we use to determine how far something fell when it fell from rest. And since our y component of our initial velocity is 0, it's as if in that direction we fell from rest. Okay? Now, the first thing we want to find is t. Now, if we look at this top equation, we do know the initial velocity in the x direction, but we do not know dx or t. We cannot use that equation to solve for the time. So we're going to have to go to the other equation because we know this vertical distance. We know g, and the only thing left is t. So let's solve this guy for time. I'm going to multiply both sides by 2. Then I'm going to divide both sides by g. And then I'm going to take the square root of both sides, and I'm going to get that t equals the square root of 2 dy over g. And now we can stick the numbers in, and we get 2 times 50 meters over 9.8 meters per second squared. And we'll take the square root of that number on our calculator, and I get 3.19 seconds. Okay, so it only takes 3.19 seconds for him to fall 50 meters. The important thing here is if you look at this relationship before we plug the numbers in, you'll notice that the time it takes to fall only depends on this vertical distance. G on our planet is 9.8. It's not going to ever change. And so it doesn't matter how fast we're going horizontally in terms of how long it's going to take to hit the ground. Okay? Now, if we want to find the horizontal distance, we pull out the other equation and we put the numbers in. So we've got initial velocity in the x direction is 100 meters per second, and the time is 3.19 seconds for a horizontal distance of 319 meters. So that's how far he moves horizontally in his fall of 3.19 seconds. Very typical problem. See you next time.